Hello everyone. In this video, we want to give you some further instructions on how you can improve your Proteus PCB design so that we can have a better fabrication of our PCB in the lab. So you need to actually follow these instructions before you come to the lab for your open-ended lab. So let us start. First, let us discuss briefly about the method we are going to use for fabrication of our PCB. So here you can see the middle one. This is basically a double layer copper board which we will use for fabrication of our PCB. I think I discussed about this board previously in our PCB design video. So basically it has three layers. So top and the bottom layers are made of copper, fully copper, and the middle one is non-conductive called FR4. So what we are going to do, we are going to just somehow fabricate the top layer at the top and bottom layer of our design at the bottom copper of this board. And to do that, we have to actually generate some files from our Proteus design. If you remember, we had different layers generated in our Proteus PCB design. So there we had top layer colored in red, then bottom layer colored in blue, then there was another layer called top silk, and we had also board edge. So different layers were there, but specifically we need to concentrate about the top layer and the bottom layer because these are the layers containing our traces and all the connections. So we obviously have to generate some files from our Proteus software. So what we will do for each of the layers, that means for top layer and bottom layer, we should generate two different PDF files, and from that PDF file we have to print that out to get these pages, one for top layer and one for bottom layer. So there, for printing out those portion, two things you have to specifically remember is that you have to use photo paper for printing. So the papers we use for generating photos, those are called photo papers. We have to use those. And as printer, we have to use laser printers because the ink we get from laser printer and inkjet printer are different, and for our task here we specifically want to have the inks generated from laser printer. So two things, one of them is your photo paper, another one is laser printers. If you want to generate your files like this, pages like this for top layer and bottom layer, you have to follow these two instructions. In our lab we have the specific printer and photo paper. So what you need to do, you have to at least generate the PDF files properly before you come to the open-ended lab. So after that, what will happen is that we will have these two piece of papers with our two layers. This one is top layer and this one is bottom layers, and we want to place these two layers onto our copper board. So for that, obviously, these two layers are facing in our direction, but the top layer should be facing towards the top layer of this copper board. So let us see how we do that. So now you see we have actually rotated the top layer so that the top layer is facing to the top layer of this board, and bottom layer is already facing to the bottom layer of the board. So now we can place it in our copper board. So in this way we'll have to place the two layers on our copper board, and we have to be very careful about the placement of top layer page and bottom layer page because they have to match up with each other. All the holes for the top layers you can see should match up with the bottom layers so that we can properly finally drill out all the holes or all the vias, all the pads for our PCB, right? So how to do that and what are the things we have to be careful about, that I will discuss now. Okay, So afterwards, what we will do is we are going to use masking tapes to actually stick the pages onto our copper board, and then we are going to use a laminating machine. So we will put this thing onto the laminating machine, and what the laminating machine will do is it will transfer the inks of these pages onto our copper board, both for top layer and bottom layer. And this is what we want, because this whole board is actually full of copper, right? Both for the top layer and the bottom layer. What we want to do, we just want to keep the coppers for the traces, the black traces we see here, both for top layer and bottom layer. Now for that, to remove the coppers, what we will use is we are going to use ferric chloride that will react with the coppers here and remove that. But we don't want to remove the coppers for the black portion, black traces we see here. And as the inks are transferred onto our copper board after lamination, as a result, what will happen, if we can just remove the paper from here, only thing that will be left on the copper board is the black traces or black inks, right? And that will not let the ferric chloride to react with those black portions here. As a result, the regions where black traces are there or black inks are there, copper will be intact. That will not get removed. As a result, after that chemical process, what we will have is just the coppers inside these black traces, and all the coppers will get removed after the chemical process, both for top layer and bottom layer. So that is the basic process, but first we need to generate the PDF files, right? So let us see how to do that. Okay, before we generate our PDF files, let us look at some of the settings we have to change to improve our design for our fabrication. Because as I had told you earlier in the previous video, that in our country fabrication of PCB is not that easy, so the trace width and everything should be proper so that the traces don't get removed, right? So let us look at those settings we can improve. So let us go to design rule manager here. So you will see under design rules tab we have this default rules, right? Double click here, you will see different rules here which we didn't change earlier in the previous video, but these are actually very important rules for our PCB. Like, what is pad to pad clearance? Obviously all the pads you can see here, like in this IC we have 7 different pads here. Each 2 of the pads, there should be some minimum gaps between them, right? And pad to trace means all the pads and adjacent trace, what are the minimum clearance we have to give for the design. And obviously trace to trace clearance means between all the traces, between 2 traces, what is the minimum gap we will allow. What happens is in fabrication, when we have 2 traces very closer to each other, that will not get fabricated properly. There will be some error because of the process we have. So we have to give higher values for each of them so that we don't have any kind of problem. So the values I will suggest you to put here is for pad to pad clearance, it should be 20 thou. Then pad to trace should be 30 thou, and trace to trace clearance should be 30 thou again. Okay, so these are the settings you have to change, and as you change this value, it will be applied for whole design in your PCB. So you can just press OK. It will be applied for top copper as well as bottom copper, and if you have multiple layers in between them, that will also be applied for them also. So we have only 2 layers, top copper and bottom copper, and that will, as you can see, that is also changed here, right? Another thing is in under net classes, previously we said that for power and signal net class we had a value of trace style and via style. What I will suggest is that you should increase the trace style to at least T40 or T50 so that you have very thick traces in your design and that will not get removed in the fabrication process. Okay, so use at least T50 or T40. And for the via style, use at least V80. Okay, so these are the settings you have to be very careful. So both for power and signals you should use at least T40 or T50, and via style should be V80, and other things will be as it is. So via type should be through hole here, and for the power also it should be through hole, and all the other settings can be kept as it is. Then press OK. After optimizing all these settings, for each of the PCB, what we want to do is we want to make our PCBs as compact as possible, as small as possible, but still we have to be very careful about the fact that the trace width should be thick enough, the distance between two traces should be good enough so that we don't have any error. So these things has to be carefully maintained, but at the same time we want to make our design as compact as possible. Some other things you can do is, the problem with our fabrication facility is that we can fabricate the top copper, the red ones, and the bottom coppers, blue ones, but the ones here, these ones are called top silk, right? We cannot actually fabricate those in our lab. As a result, what we can do is the things we want to keep in our PCB, that should be kept as top copper. Like this is right now as top silk, we can convert that into top copper so that when we print out our PCB, this thing, the name of our group should be there. So always try to keep your group name in your PCB. That is a very good practice. So what we will do is right click, then change layer, here top copper. Okay, same goes for this one, so top copper. So this is one thing you can do. Another optimization you can do here is putting some decoupling capacitors close to each of the ICs. As you can see, I have done here. So we have 6 different ICs, right? And for each of them we have different decoupling capacitors. These are just basic ceramic capacitor with 1 nanofarad value. So let us look at the 3D visualizer. As you can see, these are the capacitors placed close to each of the ICs. So why we actually do that? We do that because digital ICs can generate rapid changes in current as they switch between logic states, that means 0 and 1. These sudden current spikes can lead to voltage fluctuations and noise on the power supply lines. These capacitors we will use can act as a reservoir of charge, and they can supply or absorb current to stabilize the power supply voltage. So this will help in reducing the voltage fluctuations and ensuring that the IC is receiving the proper or stable supply voltage as it needs. Okay, so how to do that? In the schematics, what we have to do is in the previous design we had used this kind of terminal blocks and we connected ground and power here. So this power will be supplied to all of the ICs, right? So what we can do, we can just connect these 1 nanofarad capacitors, this one called cap. So as we have 6 different ICs, we can use 6 different capacitors all parallel to each other. So then after that we will see that we will have these capacitors in the PCB layout also, and we want to place those capacitors close to each of the ICs. Like we have 6 different ICs. For each of the ICs, I have placed one of the capacitors close to them. So it will provide those voltage when the fluctuations happen, because we may work on high frequency. As a result, this kind of problem can happen. Okay, so this is another advice you should follow. Now let us look at how can we generate the PDF files for our fabrication. So as I had told you earlier, we are going to generate 2 different PDF files, one for the top layer, another one for bottom layer. So to do that, what we will do is we are going to go here, output, then print layout. Then here you don't have to worry about this one, just check here, then okay. Then first thing you have to do is go here, printer, and you will see that initially maybe it will be connected to your printer, right? This can happen. So you have to keep it to one of the settings where we can generate PDF, like Adobe PDF or Microsoft Print to PDF. So both are okay. So I am going to take Adobe PDF. Then the size, the photo papers we are going to use are A4. So we have to select A4 here. Okay. So press OK here. Then as you can see the preview, and also you can move it around if you want in the A4 paper. But what I will suggest you is you should keep it as it is at the corner, so that we can print both of the layers in the same page in our photo paper. So first let us generate the PDF for bottom layer. So what we will do, on the layers we are going to uncheck all the layers except bottom layer and the board edge. It will act as the reference for our design, so we will always keep board edge both for bottom copper and top copper. So these are the two things right now we have to check. All others should be unchecked. You can keep all the settings as it is, and the reflection should be normal for this one. Then you can generate the PDF file. So let us press here, and then we need to give the name for this one. So let us call it bottom, then save. So the file is generated here, right? So both the bottom layer and board edge is here, but you will see that one of the problems we are facing here is the whole size here is very small. It is not 30 thou as we want for the pads. We will see how to fix that later on, but right now let us try to generate top layer. For that we will go to output again. Here we will uncheck everything else except top copper and board edge, right? And here in the reflection we have to keep it in mirror. So why is that? Let us try to understand. Previously we saw this animation of coppers and two layers. This one was the bottom layer, this one is the top layer, and if you look closely you will see that one of the layers is mirrored. This particular layer, top layer, is mirrored. This hole and this hole here is not correctly matching with these two, right? This is because when we want to place these two layers onto our board, both of the layers will be facing towards each other. As a result, one of the layers will get rotated like this, so it is getting rotated so that it is facing downwards and it will face upwards. And now you will see that all the things are matching up with each other. This hole and this hole, they are matching. This hole and this hole are matching, and all the other things, all the holes are matching with each other. For that, what we had to do, we had to mirror one of the layers. So what we will do is we are going to mirror the top layer, and bottom layer will be kept as it is, and then the two PDFs should be generated. Okay, so let us try to do that right here. So here we are going to take mirror for the top layer. All the other things are good, so here we will say top. The files are generated, so you see the top layer is mirrored. Okay, now how to solve this problem of the bottom layer we saw earlier. The whole sizes are not properly done. This is happening because some of the settings in the pads are not correct. So we had used these pads here, right? These are called these pads here, STD-DIL. So here if you double click here, the default setting for this is something like this. The drill hole is 30 thou, but the drill mark, this is kept as 15 thou. And as a result, we are not seeing the proper hole size as we wanted. So we want to keep this as 30 thou. Okay. Same goes for all the other pads we have in the design. Like these vias, these can also be considered as pads, right? So you have to check whether the drill mark is properly given here. The drill mark should be at least 30 thou. Okay. So like for this one, let us check which pad we have used for this one. So let us check this one. Is this the same? Maybe not. Maybe this one. Maybe 80-40. Yes, 80-40. This one. You see? Now it's matching, I think, with this one. So we have used 80-40 for our pads here. So what we want to do, we want to double click for S80-40 and check what is the drill mark value given here. So 25 thou, we should keep it at least to 30 thou. Same goes for all the other pads you can see in your design. So one of the problems solved. Another problem is again for the DIL pads we used for this IC. So here in the default settings you will see that the width here is 60 thou. We can keep it to 70 thou, so our pads will be much thicker and it will be easier to solder, easier to fabricate. So let us keep that to 70 thou. Okay. So here you will see some warnings are showing, because as we have increased the width of each of the pads, the distance between two pads has decreased. As a result, some DRC errors will generate. So we have two different DRC errors. Let us look at that, like this one. So this is pad to trace error. So we can easily solve that. Just try to move this trace here. So this is solved, and here this one also, if I just move the trace again, move this one also, now it is solved, right? So in this way, if we have some DRC error because of our optimized settings, we can change it here. Or if we have a lot of DRC errors, we can again reroute or auto route the whole design again. That can be done. One final improvement you can do in this design is you can keep some space available between your design and the board edge. This will be very helpful because we want to use masking tapes to attach these PDF files or PDF pages onto our copper board. So to do that, just go here, dimension mode, and roughly estimate the amount of space you want to give. Like let's say for now we want to give 250 thou space. That is the ideal space you can give. So this is 250. Now just modify the board edge to match with this 250 thou space. So we can just move it here. Okay, so this is roughly 250 thou. Then you can remove this one if you want. Just remove this one. So do this for all the edges, like here. Again, board edge. Then modify it to 250. Yeah. Then modify the board edge. Let us remove this one. $250. Yeah. Yeah, done. We can just remove these portions. So this is done. We can again regenerate the PDF files. Now the only thing left to do is put some reference points here so that we can match the top layer and bottom layer in the fabrication process. So what is that? Let us try to observe. So why do we need these reference points? This is because we need to match the top layer and bottom layer with each other properly so that all the holes goes through one layer and goes on to the next layer through this copper port, right? As a result, what we do, we just put some holes in the design deliberately, like we have two holes here created using via mode. So this will act as the reference point. So first what we will do, we are just going to put this top layer onto our copper board, then drill two holes, one here and one here, that will put two marks here, and when we place the bottom layer at the bottom part of this copper board, these two holes will act as the reference point for this bottom layer, and this will actually help us to match the top layer and bottom layer with each other accurately. Okay, so we have to place two vias for this reference points. So to create the reference point, what we will do is, let us go to the design again here. So we will take vias from this via mode, take V80, then place one at the corner, at any corner. Okay, we are just taking this corner, and another one we can put it at the other corner. That can be done. The problem is, you know, when you go to the design, like here, you will see that if I have the other via at the corner here, what will happen? We will have two reference point, but the bottom layer can be placed in this orientation, or if I just rotate the whole bottom layer 180 degree, even after that it can be placed. That is the problem. So as a result, what we should do, we should keep one of the holes or one of the vias here, another vias should be at the middle of the other edge, so that this error can never happen. Okay, so as a result, if I rotate this bottom layer, it will never match up with the holes we have created. Okay, so what we will do, we will just keep one of the vias here and another one should be at the middle of the other edge, roughly around here, and then we can generate the PDF file. So let us try to generate the PDF file again. So print layout, then here all the things are okay. For bottom layer, all the other layers should be unchecked and reflection should be normal, then press OK. Okay, so let us call that bottom 2 and save that out. Now you see we have two holes or two vias here in the design, and if you look closely also, the hole sizes for each of the pads have increased. Like for the previous one was this one, the hole size here is very small, right? And this has been fixed here because of the settings we have changed in HDDIL default settings. And let us try to generate the top layer. So print layout, then top layer checked, all the other layers are unchecked, also make one. Okay, so it should be mirrored, the reflection should be mirrored. Now okay, let us call this one top 2. Okay, so this is also generated, and same two holes are again generated here. These two holes or vias will be act as the reference point for our fabrication process. Okay, so these are some of the instructions you have to follow before you come to your open-ended lab. So you should change all the settings in your design, then generate all the PDF files before you come to open-ended lab. That's all for this lecture. Thank you.